An apple, a pencil, the Rubik's Cube, household objects. What are they made of? We know that everything is made out of some sort of material, but what is it made out of then? Let's take an example. If I cut a sheet of paper in half, I get 2 sheets. If I cut them in half again, I get 4 sheets. We could carry on doing this and conclude that there must be an infinite number of small pieces that consist of infinite number of pieces as well. Interestingly, it will be true for all kinds of objects. Yet, when I'm asked what I had eaten for breakfast, normally I would say, I ate an apple. And I wouldn't say, I ate an infinity, just as usual. Consequently, there must be a building block that cannot be broken into smaller pieces. This is called the atom. It comes from Greek atomos, which means indivisible. Democritus and Leucippus were coming to the same conclusion when they proposed the very first idea of atoms in 5th century BC. This concept was later polished by John Dalton in 1808. The professor added that the forces that hold matter together can change in different substances. Moreover, he said the phase depends on the distance between the particles. Still, it's just a hypothesis, isn't it? Do atoms really exist? There is a phenomenon called Brownian motion. This is the random motion of particles suspended in a fluid. Jean Perron and Albert Einstein, as they were trying to come up with the cause of what they saw, they achieved to prove the existence of tiny particles of the liquid. Years later they could be seen by electron microscopes as well. But let's not rush into the future so quickly. It turned out that the atom is not as indivisible as we thought it was. J.J. Thomson discovered the electron, Ernest Rutherford the proton, and later James Chadwick the neutron. In the center of the atom lies the nucleus, where there are the protons with the positive charge and the neutrons that are neutral. And there are the negatively charged electrons orbiting the nucleus, forming electron clouds. But how do they look like? It is widely believed that every atom looks like a little ball. Well, this is not the case. The shape of the atom is thanks to its electron cloud. How could we imagine them? The same question was raised by Niels Bohr. He found that there are certain orbitals that are available. They can neither fall into the nucleus nor be in any random point in space near it. This is due to the wave-particle duality of electrons. His model of spherical electron paths was true for the first few elements, but didn't fit for the ones with higher atomic number. Later on, Sommerfeld expanded the theory and added ellipses to the set in 1920. Finally, Werner Heisenberg and Erwin Schrödinger, based on the principles of quantum physics, created the three-dimensional orbital sets and defined their shapes. So, why is it so useful? Because, thanks to these discoveries, we could easily tell the shapes of the simplest atoms as well as complicated molecules. Take for example the methane. It has the shape of a tetrahedron. Like that. Or rather like that. Or most possibly like that. Anyhow, these models help us take the tiny and simple and understand the big and complicated. But we need to remember, to create big, we should always start small.